Morning, sixth grade. Happy Friday. We got investigation 7 today. It's talking about balancing equations. Guys, this is algebra class, and we're going to start working algebra class with a lot of letters and solving equations big time. You've been doing this really, though, for a couple weeks now. Usually letter C or D in your mental math has these equations, and so today we're just going to get the investigation that's going to really work this a lot of times for us. So cruise along and follow along with me. This investigation will show you a formal algebraic method for solving equations. The method is called balanced equations because the two sides of the equation balance each other. The picture of the scale shows that both sides of the equation are equal or they're balanced. Here's the whole key to the lesson, guys. Whatever you do to one side of an equation, you must do to the other side of the equation to keep it balanced. So there are 2 steps to balance an equation. First, you select your operation. We have our 4 operations of adding, subtracting, multiplying, dividing. That will isolate the variable. What does that mean? Isolate the variable means that you leave only the letter on one side of the equation. To select the operation to use, we always use the opposite of the operation shown. So subtraction and addition are opposite. So if they show you subtraction, you do addition. If they show you addition, you do subtraction. If they show you multiplication, you do division. If they show you division, you do multiplication. Step 2, perform the operation on both sides of the equations. Here we go. X plus 12 equals 33. So I see that it's addition, so I know to isolate x by itself, I do the opposite of addition, which would be subtraction. If I subtract 12 on the left, I need to subtract 12 on the right. So I subtract 12 on the left, it cancels that out, I'm left with just x. I subtract 12 on the right now, and I'm down to 21. They show you that right here. Subtracting 12 on both sides gets me the math. I'm down to 21. Okay, so after you do all the subtraction, then you can stick back in and you can check your answer. I think x is 21, so 21 plus 12 is 33. 33 is equal to 33. Because they balance, they're the same. Okay, so you had a page of explaining it to you. Let's start practicing it. The equation 45 equals x plus 18 is illustrated on the balance scale. This time the unknown number, the variable, is on the right side of the balance scale. 18 is added to it. What operation will you use to isolate it? Opposite of addition is subtraction. Now hopefully you can get that one, guys. If not, they're going to explain it to you in the next line. So they say, what will you do to keep the scales balanced? You will subtract. You're going to subtract 18 from what side? From both sides of the equation. And we're just going to keep saying that over and over again. Whatever you do to the right side, you have to do to the left side. Tell what will remain on the left and right side of the balance scale after the operation is performed. Okay, so if I subtract 18 up here, I'm left with just x. I subtract 18 over here. Some of you might want to write it up and down. 45 minus 18, so you can do the math. 15 minus 8 is 7. 3 minus 1 is 2. So I'd be left with a 27 over here. On the, well, both sides, guys. So this is the left side. It'll be what? 27. On the what side? Right side. It will be my x. So x equals 27. It says, here's how you do that if you're actually going to solve an equation line by line. This is what we do on our math lessons, guys, in our box. They gave me it. I subtract 18 from the right. I subtract 18 from the left. I do the subtraction. I get 0. I do the subtraction. I get 27. I do the addition. X plus 0 equals x. X equals 27. Stick it back in to solve it. Here was my equation. I stuck 27 back in. I did the math. I got 45. If you reverse the 2 trays on the balance scale so that x plus 18 was on the left and 45 was on the right, would the scales be balanced? Absolutely. Write the new equation. X plus 18 still equals 45. So guys, it doesn't matter if it's 45 equals x plus 18 or x plus 18 equals 45. They're just saying either way, you're going to get the same problem. Alright, done with page 1. Moving on to page 2. It says now let's look at an equation that has multiplication rather than addition. So this time I got 2x equals 132. 2x means that there's 2 x's, which is x plus x, and the equation can be written on the scales 2 ways. I could do 2x or I could do x plus x. Select the operation. To isolate x, you use the opposite of multiplication. The opposite of multiplication is division. So to isolate it, we divide both sides by 2. Perform the operation. So I'm going to divide by 2 on the left. I'm going to divide by 2 on the right. When I divide by 2 on the left, I'm left with just x. When I divide by 2 on the right, I'm left with 66. That's it in picture form. This is it in math form. Divide by 2 on the left, divide by 2 on the right. 2 divided by 2 equals 1, so I'm left with 1x. 132 divided by 2 equals 66. 1 times x is just x, so x equals 66. You check it by sticking it back in. Stick 66 in for 2, multiply it, you get 132. So guys, as we work through these last pages, this is what we're going to do. We're going to be doing these step-by-step checksing. Use this scale to show this equation. Instead of 2x, guys, this time you have 3x equals 132. How will you isolate the variable? How do I get rid of multiplication? I divide. I'm going to divide both of them by this number. I'm going to divide by 3. Describe the operation performed that will balance the scale. Divide both sides of the equation by the number 3. Okay? Now it says, use this balance scale to show what is on both sides of the scale after we did it. So if I divide over here, guys, 3 divided by 3 cancels. I'm left with just an x. On the right side, I have to do 132 divided by 3. 3 goes into there 4 times, that's 12. Subtracted another 12, I got a 4 there. So on this side, it would be 44. So I always divide or do the opposite, guys, to get the letter by itself. Then you do the math on the other side to get your answer. Let's keep practicing. Flip it over. It says write a line-by-line solution for this equation. Okay, they told me back on this side, guys, 3x equals 132. So 3x equals 132. Dividing by 3 on the left, I divide by 3 on the right. So I have 132 divided by 3. On the left, the 3's cancel. On the right, I do the math, and I get my 44. Now we're going to check this equation. 3x still equals 132. 3 times 44 should still equal 132. 132 equals 132. That tells me I did the problem right, guys. So if you go back over here, you see how they just repeated. That's what we're doing over here. We're repeating. Some of you say, okay, that's kind of redundant. Why are we doing it over and over again? They're just trying to pound it into your head, guys, so we do math normally. Normally you just say, all right, divide, done. They're trying to teach you algebra. And the reason they're doing this, guys, is eventually they're going to get you more and more steps. Right now we solved with just adding, just subtracting, just multiplying, just dividing. But you know from your mental math, you're going to have to do 2 steps. You're going to have to subtract and divide. And they're getting you ready for that. Most students solve the equation 3x equals 32 by dividing both sides of the equation by 3. There is another way to solve the equation. The coefficient of x is the number that multiplies x. Here, 3 is the coefficient. So any number, guys, that goes with a letter is called a coefficient. Know your vocabulary terms. Instead of dividing by the coefficient of x, you could multiply by the reciprocal of the coefficient. So instead of dividing by 3, you could multiply by 1/3. This is best when solving fraction problems. So guys, if I had this problem, I would just divide by 3. If I have this problem, I'm going to know what we're doing up here, multiplying by the reciprocal. Okay? For whole numbers and decimal coefficients, it's easier just to divide. For fractions, it's easier to multiply by the reciprocal. 11. Select the operation that will result in 3/4 x becoming 1x in the equation. In other words, what's the reciprocal? So the opposite of division is multiply by the reciprocal. Multiply by, what's the reciprocal of 3/4? 4/3. What operation will perform? You will still multiply. And you have to multiply both sides of the equation by the same number. That same number is still right here, guys. It's 4/3. Okay, page 2. Done. This felt like a thick packet, but it goes pretty fast. 13. Write a line-by-line solution of the equation. The answer will be an improper fraction. Next thing you need to know about math class for the future. In arithmetic, we usually change answers that are improper fractions to mixed numbers. What that means is when I add and subtract and when I multiply and divide just number problems, I have to switch them back to mixed numbers. However, in algebra class, guys, when there's letters, we usually leave the answer as an improper fraction unless the problem asks us to switch it back. So in the future, guys, we're going to see what we do here and then we leave it. They gave me the problem 3/4 x equals 9/10. They said multiply by the reciprocal. If I multiply by the reciprocal on the left, I need to multiply by the reciprocal on the right. Now I do the math for the next steps. 4/3 times 3/4 equals 1. On the right side, I'm going to cancel. 3 goes into 9 3 times. 4 can be divided by 2 and 10 can be divided by 2, and I multiply 3 times 2 and get 6, and I multiply 5 times 1, so I get 6/5. Next step, I take 1 times x and get x. There's nothing to do over here, guys, so I just copy it straight down of 6/5. And I'm done. It does not switch to 1 1/5. This is algebra class. Number 14 says solve it. Now this one's easy, guys. 3/4 x equals 9/10. They stuck in what they thought the answer was. It still equals 9/10. They did the multiplication and got 18/20. That still equals 9/10. They reduced 18/20 to 9/10. It still equals 9/10. So they took it easy for us on number 14. They'll eventually switch that around and make us do this stuff to solve it. Continuing on, for each of the following equations, state the operation selected, tell what operation you will perform to keep it balanced, write the line-by-line solution, and then turn around and check it. They give me x plus 2.5. The opposite of addition is subtract. Then what do I have to do? It tells you have to do step 2. You have to subtract the 2.5 from what? From both sides of the equation. Stick it back in. X plus 2.5 equals 7. Opposite of adding 2.5 is subtracting, so I have 7 minus 2.5. They did the math on the left. 2.5 minus 2.5 is 0. I do the math on the right. 7 minus 2.5 is 4.5. I'll show you that. Some of us are tempted to go fast here. You need to borrow. X equals 4.5. Let's check it. X plus 2.5 still equals 7. I stick in my answer. 4.5 plus 2.5 equals 7. I do the math. Equals 7 on the left, equals 7 on the right. Let's try this one with it backwards. This time equals y plus 2. I'm adding. The opposite of addition is subtract. And if I'm going to do it, I'm going to subtract on both sides of the equation. 3.6 still equals y plus 2. How do I get rid of plus 2? I subtract 2. Now I do the math. Y plus 2 minus 2. 2 minus 2 is 0. So I have y plus a 0. Still equals the math on the other side. They did the math for me, gave me 1.6. Y plus 0, guys, is the identity property of addition. It just equals y. Now we're going to try solving it over here. Stick in your equation. Y equals 3.6 equals y plus 2. I think y is 1.6, so 1.6 plus 2 should equal 3.6. I do the math. 2 plus 1 is 3.6. 17. I have a letter next to a number. I always ask in class, what does a letter next to a number mean? It means multiply. Then I'll ask you, and how do you solve it? You divide. What number am I dividing on? The one I want to get rid of. I want to divide by 4 to get rid of it. So what am I going to do? I am going to divide both sides of the equation by 4. 4w equals 132. Divide by 4 on the left. Divide by 4 on the right. 4 divided by 4 cancels out. I'm left with just w. Do the math over here for you. Gives me 13 is 12. Is a 12 again. Gives me a 33. So this time w equals 33. Let's check it. 4W still equals 132. They thought your answer was 33. It should still equal 132. They did the multiplication. It was 132. It equals 132. They're balanced. This time, one step harder, they gave me decimals. A number next to a letter means multiply. The opposite of multiplication is division. This time I'm dividing by that number, 1.2. Yes, I still need to divide both sides of the equation by 1.2. I hope you're starting to get into a rhythm of what we're doing here. Stick in your equation. This is 1.32. 1.32. To get rid of 1.2, I need to divide it. If I divide on the left, I divide on the right. Now I'm doing the math. Now guys, maybe you're starting to get ahead of the game and say, Mr. Bauer, you did the math here to get 33, but they gave you the math answer there. Yep, they did. They gave me the math answer here, guys. So if you don't want to do the math, you can just copy from the right, and you have it. When I divide this, I get 1.1. Let's check it. 1.2m equals 1.32. Stick in what you think your answer is. It should equal 1.32. They do the multiplication. They got 1.32. Same on the left as it is on the right. Gives me confidence that I did it correctly. Page 3. Done. Cruising on to page 4. I am missing something in addition. When I miss an addition, I do the opposite of addition, which is subtract. I, of course, have to subtract both sides of the equation, 3/4 from it. So that equals 5/6, guys. Next step, subtract 3/4 from both sides, or I'm subtracting from on the left. I need to subtract on the right. On the left, 3/4 minus 3/4 is 0. On the right, I have 5/6 minus 3/4. Common denominators would be 12. This would be 10/12 minus 9/12 would give you this answer of 1/12. X plus 0 is x. X should still equal 1/12. Let's solve it. We still think this equals 5/6. We stuck in what we think our answer is. It should equal 5/6. We found common denominators. It should still equal 5/6. We added them together and got 10/12, which equals 5/6. When you reduce it down, you get 5/6. So guys, 5/6, 5/6, 5/6, 5/6, 5/6. Last but not least is that coefficient talk we had. I have missing a number in multiplication. You would normally say, well, then we divide. But when it's a fraction, we multiply by the reciprocal. So I multiply by the flip 4/3. So we are going to multiply both sides of the equation by 4/3. So 3/4 x equals 5/6. Multiply 3/4 x times 4/3 on the left. Should be 5/6 times 4/3 on the right. 4/3 and 3/4 is my inverse property. Cancels out, gives me 1. Doing the math over here, guys, I'm going to divide by 2, gives me 2. I'm going to divide by 2, gives me 3. Multiply the top. 5 times 2 is 10. 3 times 3 is 9. I write that here as 10/9. 1 times x is x. X still equals 10/9. Let's do the whole thing now. So now we got to do all of this, guys, with this equation here. So 3/4 x equals 5/6. Step 1, I have 3/4 times what I think my answer is, which is 10/9. I still think that equals 5/6. I do the math. 3 times 10 is 30. 4 times 9 is 36. I still think that equals 5/6. I reduce 30/36 to 5/6, which does equal 5/6. So they're slowly making it you doing more and more of the writing. By the time we got to problem 20, guys, we were doing a majority of the writing, so you're ready. Let's do a few more for the extensions. It says write and solve an equation for the problem. So here's how we use algebra in real life, guys. Marcia hiked a total of 12 miles on 2 trails in a national park. One trail was twice as long as the other. How long was each trail? Let's let S be the shorter trail. So if S is the shorter trail and this one's twice as long, then the longer trail is 2S. So I have shorter trail plus longer trail equals 12. So it looks like this. The shorter trail plus 2S equals 12. This is really 1s plus 2s. Well, 1 plus 2, guys, is 3s equals 12. So I'm going to take this, I'm going to divide by 3 on the left, I'm going to divide by 3 on the right. The 3's cancel, I'm left with just s. I do the math, 12 divided by 3 is 4. So s equals 4, so this one is 4 miles. 2 times 4 is 8, this would be 8 miles. And 4 plus 8 gave me the 12 total miles she walked. So this is taking a word problem, guys, that you will get in the future, switching it to algebra, solving the algebra with today's lesson, and getting our 2 answers. Jake earned 50 bucks. He put half of his money in the bank. He spent half of the money he did not put in the bank. How much money did he have left? So let's let M equal money Jake has left. Money Jake has left equals M. Money Jake spent. Well, Jake spent half of his $50, guys. So I'm going to take 50. I'm going to divide it by 2. I'm going to get 25. Jake spent $25. Money Jake put in the bank is your other $25. Put half the money in the bank. He spent half of the money he did not put in the bank. So what I got to do half again. Sorry. This one went down here, 12. Okay, so I would have M, money Jake has left. I would have to do 25 and divide it by 2. That goes in there once. That goes in there twice. That's a 4. I subtract, I get a 1. Add a decimal, add a 0, bring it down. 12. 2 goes into 12 5 times. So Jake actually, he spent money in the bank. How much did he have left? So he actually spent, $12.50. How much did he put in the bank? He put half it in the bank. That's the 25. So money he has left plus what he spent, $12.50, plus the 25 equals the 50. I add those together, guys. It's the other half of this one. So he has $12.50 that he has left. Mr. Wang's business averages all that in expenses each month. The company's salaries average that each month. The rent for the company is that each month. How much should Mr. Wang budget for salaries, expenses, and rent for the year? Well, he should take total number 1, which is $14,250 per month. He should take salaries, which is $26,395, and he should take his rent, which is $28,25. He should add those all together. That's how much he would spend in a month, and then he should take his answer times 12 months because there's 12 months in a year. All right, I'm going to write it over here so it's up and down for me. And we're ready to add it. 5 and 5 is 0. Carry the 1. 1 and 5 is 6, 15, 16, 17. Carry the 1. 3, 6, and 8 is 14. Carry the 1. 5, 11, 12, 13. Carry the 1. 1, 1, 2 is 4. He spends $43,000 every month, and now I have 12 months of that. 2 times 0 is 0. 2 times 7 is 14. Carry the 1. 2 times 4 is 8 plus 1 is 9. 2 times 3 is 6. And 2 times 4 is 8. Add a 0. 1 and 0. 7, 4, 3, 4. 0, 4, 16, 11, 12, 5. My goodness, he spends over $500,000. He spends $521,640. And I put my dollar signs in there, now I did. That's a lot of money. Last but not least, it says, look at the 4 equations below. Which equation does not belong? I don't know, let's solve them. I get rid of 4x by dividing by 4. When I divide by 4, x equals 2. I get rid of adding by subtracting. 132 minus 130 equals 2. Missing a number in multiplication, I divide. 66 divided by 22, x equals 3. Missing something in addition, I subtract. 14 minus 12 is 2. Which one does not belong? Wham! 22x equals 66 doesn't belong because x equals 3. Alright guys, you got your steps to completion of balancing an equation. That was 8 pages of awesomeness that we loved. Extra credit, you go to the top right here and you write, I love algebra. Man, it's so much fun when we can solve equations, and I can't wait to get to the much more complicated equations we're going to get to in the last 50 lessons in our math book. Alright, have a great weekend, guys.